Hi, Algebra 1. So we're going to go ahead and move on to the next section. We're going to go ahead and call section 6.1 done, since we've spent a couple weeks on that section. And the next section we're going to cover is 6.2. So we're still solving systems of equations, linear equations, only we're going to be utilizing a different method this time. It is called the substitution method. So let's go ahead and dive right in. So I try to break things down into repeatable steps for you when possible. So to solve a system of linear equations using substitution, I'm going to say that step one, which you may or may not always need to do, but step one, you want to isolate a variable in one of your equations. And that doesn't have to necessarily be the y variable. It can be the x. Okay, so basically you want to just look at one of your equations and get the y by itself for one of them, or get the x by itself, whichever is easiest. And like I said, you may not always need to do step one. You may already have an equation where there's a variable isolated. Step two, you're going to substitute that expression. I can type it correctly, substitute. Substitute that expression from step one into the other equation for that isolated variable. So step two might not make a lot of sense because I'm typing it all out. It'll make sense as I do examples. So basically what you're going to do, if it's not already done for you, is you're going to isolate a variable in step one. So for example, you'll have y equals and then some sort of expression. You're going to take that expression and substitute it for the y in the other equation, because remember, we've got two equations. So once you've done that, step three, you're going to solve for the variable, because at this point you should only have one. So I might actually put that in parentheses. You should only have one variable at this step. So either an x or just a y. You shouldn't have x's and y's. It shouldn't be a mix. And then once you've got that variable, you'll get like a variable equals a number. You're going to substitute, if I could spell it correctly, I keep misspelling that, substitute your known variable into the other equation. Oh, actually, it's not necessarily the other, it's into either equation. Substitute your known variable into either equation to get the other variable. So for example, in step three, if you solve your equation, you get y equals 3. Take that value for the y, substitute it into either equation, the original equations with x's and y's, to get the other variable, okay? So you may want to refer to these steps if you forget how to do things. And as always, I encourage you to rewatch examples in this video if you're getting stuck on your online learning slides. Okay, so let's take a look at the first system. So we have y equals 6x plus 10 and y equals 7x plus 13. So step one told us to isolate a variable in one of the equations. Well, as you can see, I don't need to do that. I have a variable isolated. I have a variable isolated here, and I have a variable isolated here. So I'm good to go with step one. So like I said, you might not need to do that step. Step two, though, said to substitute that expression from step one into the other equation for that isolated variable. Well, let's take a look at this. What variable is isolated? Well, it's the y. So what step two is actually telling me to do, it's telling me to take this expression and substitute it for the y, but in the other equation. So basically, what it's telling me to do is it's telling me to replace, let me actually just rewrite that equation, 7x plus 13. And let's make all of this, oops, not bullets. I want it to be, oops, yeah, single spaced. Hopefully that won't put as large a gap. So what that's telling me to do is it's telling me to take this y and replace it with the 6x plus 10, the expression that the y was equal to in the other equation. So at this point, you should have an equation in one variable. There are no more y's at this point because I replaced it with the expression it's equal to. I substituted this y with this expression because, as we were told from the first equation, that's what y is equal to. Well, if I have a y right here, I can replace it with what y is equal to. I can substitute. So step 2 is done. Step 3 then says solve for the variable. And as a reminder, you should only have one variable now. And I do. I only have x's. I only have the one variable. So at this point, this goes all the way back to chapter 2, where we had equations that had variables on both sides. So I want to get my variables to one side. I could either move the 6x over to the right, or I could move the 7x over to the left. It doesn't matter which one you do. I'm going to subtract the 6x over to the right, so that way in my next step, I have a positive 1x, or just x. You don't have to write the 1 in front, but I still have a plus 13. To get rid of the 13, it's a one step now. I just subtract 13 from both sides. I should have started over here because I'm going to have to do it here anyways. So I'm going to subtract the 13 from the left and the right. They're going to cancel on the right, and I'm going to get negative 3 equals x. 10 minus 13 should give me negative 3. Okay, so I finished step 3, which says to solve for the variable. I know that in the point of intersection, whatever point of intersection it is, the x value in that ordered pair is a negative 3. So you could actually solve this by graphing probably and get your ordered pair. But substitution sometimes is just a nicer way. Sometimes it could be a little quicker than graphing, okay? It's always good to have an arsenal of different strategies. All right, so step 4, substitute your known variable into either equation to get the other. Well, my known variable is x. I know that x is negative 3. So what that's telling me I could do, and I'm actually going to have to insert a text box because I've run out of space here. What it's telling me to do, whoops, I want it to be the same font and a little bit bigger. It's telling me I could take this and substitute it for an x into either of these equations. And it doesn't matter which one you choose, okay? So I could take y equals 6x plus 10. And then in my next step, just replace the x with the value I know it's equal to. Okay, so now I can actually solve this equation for my y. And all I do is I multiply first. 6 times negative 3 gives me negative 18, plus 10 comes down for the ride. Negative 18 plus 10 gives me negative 8. Okay, so I have my y value, I have my x value. The last thing that I need to do, if you recall, when we solved this by graphing, our last step was to put it all together as an ordered pair. So my solution here is the x value goes first, and that was negative 3, and the y value goes last, that was negative 8. So to recap what we did, I'm not going to jump back to the step slide, I'm just going to say them here, but you're using those steps here to solve a system. Step 1 is to ensure that a variable is isolated. You might not need to do that. Here, we didn't. Step 2 said to take the expression that isolated variable is equal to, substitute it for that same variable in the other equation, which is what I did here. Step 3, solve for your variable. You should only have one at this point. I had the variable x. And then step 4 is to take that known variable and substitute it into either equation. I could have used this equation as well, and I would have gotten the same answer. I could do it really quick right now, just mentally. So if I replaced the x with a negative 3, I would have multiplied first, and that would have given me negative 21. And then if I had added negative 21 with 13, that would have given me -8. So no matter what, you're gonna get the correct value so long as the process is correct and the arithmetic is correct. So just a reminder, if you're doing this mentally, double check your mental math with a calculator. Okay, let's do another. Step 1, isolate a variable. Again, we don't have to do that. Both of our variables are isolated here. So I can take the expression that y is equal to and replace the y in the other equation. So I'm actually going to do that. I'm going to replace the y with negative, you know what, I should probably be typing this because you guys won't be able to copy paste. So I'm going to retype that bottom equation. And you don't have to always substitute the first into the second. Like I could substitute this into the top. In fact, let's do it like that. Let's actually do the y, whoops. I'm trying to color code things for you guys so it's a little more clear. Let's do y equals -2x minus 2. And instead of y, I'm going to substitute what y is equal to in the second equation. So it doesn't matter which way you do it, so long as the process is correct. Okay, so all I did is I took what y was equal to and I replaced y with that. So now I have an equation in one variable. That one variable is x, and I can solve for it. To solve it, I want to take all of my x's and get them to one side. Again, I could subtract the 3x over to the right, or I could add the 2x over to the left. I'm going to add the 2x so I get a nice positive term. 3x plus 2x gives me 5x. The plus 8 comes down for the ride. These cancel, and I'm left with a -2. Now I have to solve a two-step. Subtract the 8 from both sides. I get 5x equals -2 minus 8 more gives me a -10. And then last but not least, I have to divide, and that's going to give me x equals -2. So I have my x value. So the next step, and the next step for me is to insert a text box because I'm out of space. The next step is going to be to take this value that I just got, and I can substitute -2 for either of these x's in either of these original equations. Again, it doesn't matter which one you do. I could use the purple equation if I want to. Y equals 3x plus 8. And then in my next step, just replace that x with the number I got. Notice how when I do this, I'm using parentheses. It's important that you utilize parentheses because remember, in this expression here, 3x, that means 3 times x. So you want to make sure that you're using some sort of multiplication symbol. If it's not a parentheses, use like a multiplication cross or square brackets, just something that indicates that you're multiplying. Otherwise, it's going to look like this. What does that look like to you? That looks like subtraction. I don't want it to say subtraction because that's going to change the operation. All right, now we solve. Multiply first, that's going to give us -6. Plus 8 comes down for the ride. And then last but not least, -6 plus 8 gives us +2. So I have my x, I have my y, I put them together in an ordered pair. The x value goes first, that's -2. The y value goes last, that's +2. And there's my answer. So just a reminder, I did show you how to do this in section 6.1. If you're not sure if you're getting the correct ordered pair, you should do a check. You simply substitute -2 for the x, substitute +2 for the y, evaluate and see if the check comes out correct. You would have to, again, do this for both equations, not just one of them. Just because it works for one doesn't mean it's going to work for both. All right, let's do another example. So y equals 2x plus 7, and then -5x minus 2y equals 22. So this one's in standard form. So step 1, isolate a variable. Again, I'm lucky. I have a variable isolated. It's the y. So what I need to do is I need to substitute this expression for the y in the other equation because this is what y is equal to. That's what this top equation is telling me. y equals this. Well, that's not going to change for this equation if it's part of the system. So I'm going to take this equation, I'm just going to rewrite it, and I'm going to replace this y, and again, use parentheses, with everything that y is equal to, 2x plus 7. So again, if you don't utilize parentheses, you're going to lose this operation of multiplication, which is what's happening here with this -2 and this variable. So it's a little bit of a more complicated equation now. As you can see, I got to handle those parentheses first. So remember, when we see parentheses, think distributive property. I'm going to distribute this -2, including the negative, into each of these terms. The 5x is just going to come down for the ride, and I start distributing. -2 times 2x is going to give me -4x. -2 times 7 is going to give me -14. And the equals 22 just comes down for the ride. Okay, so we're just simplifying a little bit further by combining these like terms. -5 minus 4x, same signs. I combine them and get a -9x. Everything else comes down for the ride. Now I can start solving. It's a two-step. I'm gonna add the 14 first, both sides. I still have a -9x on the left. 22 plus 14 is going to give me 36. And then to get x alone, I'm going to divide both sides by -9. That's going to give me x equals -4. So now that I have my x value, I can substitute that number for the x into either of these equations. I always like to go for the one that looks the easiest. Think about it. You're substituting the x in order to solve for the y. So eventually you're going to need to get the y by itself. Well, if you look at that first equation, I've already got the y by itself. So after I substitute, all I need to do is evaluate. If I use this bottom equation, I'm going to have to substitute. I'm going to have to get rid of this term by doing an inverse operation over here, and then get rid of this number by dividing everything by -2. It's going to be a little bit harder to solve, okay? So I'm going to take that first equation, y equals 2x plus 7, and in my next step, instead of 2x, it's going to be 2 times -4. All I did is I substituted this number for the x. They're interchangeable because they're equal to each other. And now I just start solving. 2 times -4 gives me -8, plus 7 comes down for the ride. -8 plus 7 gives me -1. Forgot my equal sign. Now that I have a y value, I can put everything together as an ordered pair. I get -4 for the x value, -1 for the y value, and I enclose it in parentheses. Okay, let's try another one. Number 4, -2x plus 2y equals 6, so nothing isolated here, but in equation 2, my y is isolated, so I got lucky again. So I can take this expression that y is equal to and substitute it for the y in the top equation. So I'm going to just start by typing that first equation, because I'm going to have to substitute into it. Always start with the equation that you're going to substitute into. And I'm going to take this y, and I'm going to replace it with everything the y is equal to in the second equation. Remember, use parentheses. I cannot stress this enough. If you do not use parentheses when you substitute like this, you will not get the correct answer. All right, so step 2 for solving here, I'm going to have to distribute by taking this 2, this +2, which is touching the parentheses, and multiply into each of these inside terms. 2 times -8x gives me -16x. 2 times -21 is going to give me -42, equals -6 comes down. I'm now going to combine my like terms. They're both negative, so I add them together and get negative 18x. And then the minus 42 equals negative 6, comes down for the ride. Next step, add the 42 to both sides. I still have a negative 18x equals, and then I'm just going to use my trusty calculator so I don't make a mental math error. I get 36. Negative 6 plus 42 gives me 36. And then last step, divide both sides by negative 18. Oops. That's going to give me an x value of negative 2. Okay, I probably should have made all of this black so it's consistent with color coding. So I'm going to take this and insert a text box here. And now that I have my x value, I can substitute that x into either x in either equation. Okay, again, go for the route that you think is going to be easiest. It doesn't matter which one you use. In fact, to demonstrate, I'm going to use the harder equation and show you that you can still solve for the y. It's not the equation I would use. If I was solving for y, I'd use the purple equation. But just to show you how you would if you inadvertently started doing this, all you would do is you would take the, go back in the text box. I lost my text box somehow. I'm not sure how. There we go. Not sure what happened. It's not letting me. Okay, here we go. Technical difficulties here. So all I'm going to do is I'm going to replace the x with the number that x is equal to. So as you can see, it's going to be a little bit harder to solve for the y here, but it's not that bad, to be honest. So it's not a huge deal if you end up using the quote-unquote more complicated equation. All you'll do after substituting is wherever you see some multiplication, take care of that first. So negative 2 times 2 gives me 4. The plus 2y equals negative 6, so just come down for the ride. And then you just solve the two-step. I'm going to subtract the 4 first. Subtract the 4. I get 2y equals negative 10. Divide both sides by 2. Divide by 2. And I get y equals negative 5. So once you have your y value, you're going to put the x value first in an ordered pair and the y value second. Okay, so as you can see, even if you use the more complicated equation, it's not that bad so long as you have a strong foundation from chapter 2 with solving equations. All right, last one that we're going to do. So I'm going to take the x value this time. That's what's alone. And I'm going to substitute this expression for the x value. So as you can see, it's not always the y value that's isolated. Sometimes it's the x. So I know I'm going to need to substitute this into the purple equation. So since I'm substituting into the purple equation, I'm going to rewrite it. And then I'm going to replace this x. Remember, in parentheses, I'm going to replace the x with the expression it's equal to. And now I solve the multi-step equation. I'm going to distribute first. So negative 6 is what's touching the parentheses, so that's what I need to multiply. My first product is going to give me negative 12y. Negative 6 times negative 9, I'm going to get a positive here, and I'm going to get positive 54. Don't forget there's still a plus y and then equals negative 1. That all has to come down for the ride. Now I have one equation and one variable, and it's the y that we're going to get first this time. Negative 12y plus 1y is going to give me negative 11y. Their signs are different, so I got to take their difference. The plus 54 equals negative 1 comes down for the ride. I'm going to have to subtract the 54 from both sides. So I'm going to get negative 11y equals, these are both negative, so I'm going to add them and get negative 55. and then I'm going to divide both sides by negative 11. That's going to give me y equals 2 negatives when I divide, gives me positive, and it equals 5. So now that I have a variable solved for, I can take that variable's value and I can substitute it for that same variable in either of these equations. But you're going to substitute for the y this time. I'm just going to, for the sake of time, go for the quicker route and take that top equation, because I know I know that I'm solving for the x, right? That's what I'm trying to get. I have the y, I need the x. So if you need the x, go for the equation where the x is already by itself. It's going to be a little bit easier. So I'm going to take this and replace the y with parentheses, because remember, this means multiplication, so I need parentheses, and then I replace the y with 5. Then I simply simplify and solve as needed. 2 times 5 is what I do first. That gives me 10. Minus 9 comes down. I subtract last and get 1. I have an x. I have a y. I have an ordered pair. So all I need to do is put it together. X value goes first, so that's 1. Y value goes last, that's 5. And there's my solution. So our homework for this week: Wednesday, complete your online learning slides by 2 p.m. And then Friday, I'll have a worksheet with pretty much the same thing, solving systems by substitution. So to recap, you're going to make sure that a variable is isolated. Pretty much in all of them, I'm going to give that to you. You're going to take the expression that's equal to an isolated variable, substitute it for that same variable in the other equation, solve for that variable, take that known variable, substitute it into either equation, solve for the other variable, write your answer as an ordered pair. Okay, so go ahead and give the online learning slides a try. Remember to click turn in when you're finished, so that way I know to grade it. And as a reminder, if you're getting things wrong, I'm going to be leaving feedback. Use that feedback to make corrections and resubmit it for a higher grade. Okay, and reach out if you have any questions, guys. Take care.